What up, dudes? I'm going to help you out with some 7 and 8 on function 6, and we'll see what we can do. Man, that's small. I can barely read that. Let's make it bigger so we can say, a basketball wishes to dunk a ball and must jump to a height of at least 11 feet since the rim of the basket is of 10 feet from the floor. As they are doing so, they must counter the force of gravity much as you do when you try to toss a ball in the air. The formula for the height of the ball is given by that. So, actually, this is exactly what I was talking about. H of t is equal to negative 16t squared plus v naught t plus h naught. This is actually exactly physics. This is the equation I give you in physics. And remember what I just said is when I solve for t, I'm usually trying to get a quadratic answer, so I always throw in that extra plus or minus, and then sometimes the negative time doesn't relate to actual what works in the real world, so we throw out that negative answer. This is exactly the problem that I'm interested, was talking about when we were going over chapter 7 stuff. Anyway, okay, so what are we trying to do? Shaquille, all right, so let's see. Below is a table that shows the reach, the highest point that their fingers can reach, standing at the flat-footed on the floor and outstretched arms. Some of the most famous basketball players, and the highest point that they can jump and touch. We can assume that the difference between their highest touch and their highest reach is how they, and their reach is how high they jump. Oh yeah, okay, all right, I see what they're doing. This then allows us to assume that h naught is equal to 0, reducing the formula to that. All right, so basically here's your new formula, h naught is equal to 0. What they're talking about is, you guys ever try to calculate your vert? And what they mean is, you basically stand up and you reach up as high as you can. You take a piece of chalk and you mark that with your fingers. Then you jump and you try to see how much higher above that distance you can get. And whatever the difference is, that would be how high you can jump. Okay? So let's look at Kobe Bryant. Kobe Bryant. He can jump, and his fingers can touch a mark on the wall that's 12 feet high. That's pretty tall. When he stands and he reaches his arm up, it's 8 feet 10 inches. So therefore, I would conclude that he can jump 2 feet 2 inches. Right? No, 3 feet 2 inches, sorry. Because 12 minus 8 is, well, 12 minus 9 is 3, and you have the extra 2 inches to make it 8, 10. All right. Do you guys understand how I got that? So I'm looking at this data over here, and I have 8 feet 10 inches, and I have 12 feet, so I just subtract the 2, and I end up getting 3 feet 2 inches, and that's actually not what they asked for. They're asking for what is the height in only inches. So you convert that, and you make that, okay, 3 feet 2 inches is really 36 inches plus another 2, so that's 38 inches he can jump. Got it? Or, if you divide this by 12, you'll probably end up getting 3 point... Alright, what is 38 divided by 12? Someone do it on the calculator, please, quickly, hurry up. And I'll try to think if I can figure it out in my head. 2 12ths, that's 1/6. Yeah, 2 12ths, that's 1/6. That's like 0.15, 1/6 or something like that. You guys got it? 38 divided by 12 is what? 30 is 3 point what? 1 something. It's got to be 1 something. Come on, you guys, do it on the calculator. Do it quick. 1/7. I'm going to guess that. That's my guess. What is 38 divided by 12? Is anyone here? Is anyone listening? Good, you guys are still alive. There we go. Oh, I got it the first time. It's 3.16. I am so smart. I just made it up. All right. Anyway, that's their feet. That's how many feet they can get to. So really what this question is asking you is it's saying, what is its initial velocity? Well, what is their initial velocity? Well, how would you calculate that? Find the jump. All right, so here's your jump. Here's your height, your initial velocity. You know what? I feel like they're not giving you an equation. And I can tell you what that equation is. Oh, okay. It's just asking you for that. All right. It's asking you to find the height. So we did that. We're good. All right. Find the equation of the vertex for h of t in terms of v naught. Oh, okay. So if their height, if his height, let's work with just Kobe Bryant. If his height is 12 feet 5 inches, or 12 is 3 feet 16 inches for there, then all I got to do is figure out the equation for the vertex of this. So let's see. I've got h of t is equal to negative 16 t squared plus v naught times t. If I'm going to figure out where that vertex is, I think the easiest thing to do would be, if I want to figure out where the vertex is, the easiest thing to do would be to complete the square. Or what I could do is I could factor it. Let's factor it. Let's try to see that one. So if I factor this, I can factor out a t, and I have t times negative 16t plus v naught. Got it? Does that make sense? All I did was I pulled out a t out of 1. And then what I'm going to do is I'm going to say, all right, I'm going to set this equal to 0 because I want to figure out at what times is this person on the ground. Does that make sense? So at what time is that person on the ground? So what I can say is, all right, well, they're on the ground at t equals 0, or negative 16t plus v naught equals 0, which tells me that negative 16t equals negative v naught, which tells me t equals v naught over 16. Got it? Does that make sense to you? Did I just speak crazy, or do you understand? I kind of hate to do this problem for you because it's very interesting. I think it is. But I can see where you guys could have trouble with it, so I'm going to help you out here. Anyway, this is the times in which the height is equal to 0. So this is when they're on the ground level. And so we know that the vertex is going to exist where? This is at time 0, and this is at time whatever this is, v naught over 16, whatever that number comes out to be. So the vertex actually exists between these 2 points, halfway in between here. So how do I figure out the halfway point? Well, I can just add these up and divide by 2. Well, so if one of them is 0, I can really just take that and divide it by 2. So this is at time v naught over 32. Because 1/2 of v naught times 16 is v naught over 32. Then, what I can do is I can take that time and I can plug it into here. So, I end up getting h of t is equal to negative 16 times v naught over 32 squared plus v naught times v naught over 32. Is my voice echoing? I don't know. I don't know why I would do that. Is it hard to hear me? Can you guys hear me? Alright, I think that maybe the computer might be glitching out at this point. Alright, but if you guys can still hear me, then we're good. By the way, what is 32 times 32? I'm not very good at that kind of math. What is 32 times 32? I'll just put 32 squared. Alright, and then over here I have plus v naught squared over 32. By the way, I want to combine these fractions. This is 1040, this is 32. In order to make this 1040 as well, I need to multiply both the top and bottom by 32. Then I can add these. So really what I'm dealing with here is negative 16 plus 32, which gives me positive 16 over 32 squared. Cool? And then I think I can play with this a little bit and make this a 2 down here and cross that out. I can kind of reduce fractions. So I end up getting h of t, my height, is equal to v naught squared over 64. So that is my height as a function of velocity. Or, I should actually not call this h of time, because I'm talking about a very specific time. I'm going to call this h little word max on the bottom. Because it's not, this isn't the h, this is the h at any given time, but this is the h at a very specific time. At the time v naught over 32, whatever that answer comes out to be. Whatever the velocity that they jumped at divided by 32 is. And apparently that is the time at which the vertex hits. So I'm calling it the height. The highest height that they can reach happens at v naught squared over 64. Let's see what else they're asking. Solve for v naught so that the vertex will have the desired jump height at its maximum. Oh, okay. Well, all you got to do is just get v naught all by itself from this equation down here. Let me draw this up here. A little arrow. If I have this equation, h equals v naught squared over 64, I can just go 64 times h max equals v naught squared. Square root both sides, so I have v naught is equal to plus or minus the square root of 64 times h max. Hey, I know what the square root of 64 is. That's 8, isn't it? So it's v naught is equal to plus or minus 8 square root of h max. That's my answer for that. I don't know, can you guys see that, or is that hard to see at this point? I'm running out of room. I better start erasing things. I have to erase this, but don't worry, you guys can rewatch the video if you guys want. I'll write down what I wrote up here. So that would be v naught equals plus or minus 8 the square root of h max. Is that better? It might be a little bit better. It might be junk, I'm sorry. Find the general formula for the time in the air by finding the zeros for the general height. Oh, okay. Darn, I just erased that equation. That equation was basically just setting h of t equal to 0. And actually, I just had those. Either time equals 0 or time is equal to, what was it? It was like v naught over 16. Huh. I've never had that happen before. Apparently support is on our computer. Alright, I'm going to chat up with them. Alright, so anyway, did you guys have any other questions? So, by the way, based on the height, you can now, from here, this height over here, you guys can now calculate out the velocity that they jumped at. Because you have the height that they jumped at. So now you can figure out the velocity that they jumped at. What's the word in, I can't see that, in the square root? Oh, that says h little word max, M-A-X. That's because I'm talking not about h as a function of time. I'm not talking about any height. I'm talking about the very specific height. The height that is your maximum height. Because I plugged in, instead of having h as a function of t, I plugged in the time v naught over 32 into here. That gives me a very specific height. It gives me the height at exactly the middle point of when he lands. And since it's a parabola, the middle point of when he lands is called the vertex. So it's talking about that specific height. Are we cool? Alright, let's stop this thing.